Okay, so this is the lesson that we're going to cover today in a number of videos, and it's called In Behavior of Polynomial Functions. And so we're going to um, identify power functions and polynomial functions, identify a graph if a graph is a polynomial function, and to really determine that behavior. That's really the key objective. And so let me uh, take a look at some things that are important when we're looking at a polynomial. um, Polynomials look like this. They would be something like y is equal to, say, 2x squared plus, say, 3x plus 2. That's just an example of one. And if you notice, let me do another one. Maybe we have 4x to the fourth power plus 2x squared minus 7. So that's what basically polynomials look like. They're equations of this form: ax n plus b x n minus 1, and so on. And then until you get to, say, uh, let's use um let's say t x plus say u. Hopefully that doesn't make you think that that's how many um coefficients there are based on the number of letters in the alphabet. I was just trying to illustrate quickly, but the main thing that you need to know is that um if they have a degree 2, then essentially the ends are going to look like this. And then there's just going to be some different things happening in the middle, depending on the degree and depending on whether it's even or odd. Whenever it's even, it's going to uh, be the case that the curves go in the same direction. If I had done, instead of, say, let's do minus 2x squared minus 3x plus 2, then that might make a quadratic that goes this way. The negative is going to make it go down. But if you choose a higher degree, let's say negative 5x to the sixth power plus 2x squared minus 4, could even do an x there, then just something different is going to happen here, but the end behavior is going to look the same. And of course, we'll talk about what this means later. If the powers are odd, so let's just do one example. Let's say y is equal to 3x to the third power plus x squared plus 4x, let's just say. So that may make a difference what happens in the middle, but in the end, if this is positive, then it's down on the left and up on the right. And very similarly, if you change the sign of the leading coefficient, it's going to go the other way. So that's why we have in the next slide something that we're going to evaluate, which is this equation here. And there's enough information here to draw a conclusion about the end behavior, primarily because it has an even power. And also, so this is the even power on the leading coefficient. There are actually no other coefficients because it's just a one term. And then also the sign on this one means that it's going to have a certain shape. It's going to look something like this. And so the even tells us that the ends go in the same direction. So very roughly, I could draw, say, a sketch. And I know that my curve, there's some other clues in here that are telling me things, but and I just did that backwards. It's actually gonna go down. Maybe the way I drew this is not so accurate, but we're really interested in the end behavior. So the way you say this technically is you say as f of, actually you say as x goes to minus infinity. In other words, as we're going this way, f of x goes to minus infinity as well. So as you go left, you go down. That's one sort of colloquial or simple way of saying that. And as x goes to positive infinity, f of x also goes to negative infinity, like it did when it was going the other way. So as you go right, the curve goes down. But this is the technical way of saying that.